Well, what exactly is integration? Well, integration is the idea that we can study areas under curves. Well, this is very useful, especially for architecture, game development, things like, let's say, for instance, some person has a disease inside of the kidney, and we want to measure how much of the kidney has been affected, so we know how to perform a surgery. I'm not a doctor, but yeah. But before we start into that, ladies and gentlemen, let's first look at this. We need to know how to find the area of geometrical shapes, known geometrical shapes. So let's look at this one. Let's assign some values. 4, 6, 10. Okay. So what exactly is this? Well, I'm going to show you guys something very interesting. This is an area of a trapezoid. And the area of a trapezoid, let's add, or trapezium, depending on where you were born, Europe or America. So that would give me the half of base plus, and the sum, or multiply the sum of the two parallel bases. So these lines have to be parallel in order for this to work. So we can say, well, the half of 4 plus, or multiply the sum of the bases, that gives me 32 units squared. What if I had to ask you, well, is there another way to find this area? Well, is there? I could add a height and create a small little triangle. All of a sudden, we have a base of 4 and we have a height of 4. Let's see what happens now when we want to find the area of this figure. Now, instead of it being a trapezoid, we're now looking at a figure. So now, this would be known as region 1 and region 2. So can we find the area of region 1? Well, we know the properties of a rectangle is that the opposing sides are equal. So if this one is 6, that one's 6. So let's see. So let's calculate the area of the figure. Let's find region 1. Region 1 is the length times the width. This gives me 6 times 4, which is then equal to 24 units squared. What about region 2? Well, region 2 is equal to half of the base, this is for a triangle, multiply the height. The half of the base is 2, the height is 4. That gives me 8. So I have 8 units squared. Now all of a sudden I can say, well, region 1 plus region 2 is equal to 32 units squared. And look at that. Can I do it again? Is that possible? Well, let's see if you can figure out the idea. Well, what if I draw another line in here? All of a sudden we have a rectangle plus a triangle. What if I draw a line in there? I have a square plus a square plus a square plus a square plus rectangle. Now I have 5 regions instead of 1. What if I divide this up into even more little squares? Well, now I have 1, 2, 3, 4, 5, 6, 7, 8, 16, 17 regions. What about if I divide those squares into more squares? All of a sudden I have an exponential growth in regions. So what does that tell us? Can we do this with this type of function? Well, if you zoom in, you can actually draw a whole bunch of tiny little rectangles underneath this curve. Unfortunately, I cannot zoom in because at the moment I don't have the applications ready to perform such 3-dimensional applicational reviews, but hopefully soon. Okay. But now, what is the error in this? Well, if you see there's like a tiny little spot where you can still see an area. So for that, we found integration. But before we can do integration, it's very important for us to be able to find the area under known geometrical shapes. So what if I give you an interval of 0, let's put an interval 0 and 5, and I ask you find the area that's bounded to this interval, where we have the function, the f of x is equal to 2x and x is equal to 5. What if I ask you that? Well, all of a sudden, we are required to draw a function, draw 2 functions. So the first one, I have a linear function where x is equal to 5. So x will be equal to 5 at this point. Let's give our function a name. X is equal to 5, linear function, straight line. And if I have another function which would be in slope-intercept form, I know that my function would look something like this. With a slope of 2, remember, as you've seen in the previous videos, this one refers to the slope or the gradient, which means I'm going to move 2 up, 1 right. 2 up, 1 right. 2 up, 1 right. Whoopsie. Mine is a little bit off the charts, but it's okay. So how do I find this point? Because I need it, right? Well, because my question states that I need to find the area under this triangle that's bounded inside the region. So what do I do now? Well, now I can use my solution point method that I've learned in algebra. What does that mean? That means I set my two equations equal to one another. So in this case, we know that x is equal to 5. So I can simply well say then my y, if x is equal to 5, my y will be equal to 2 multiply the x that's given. So I'm just going to direct substitute. This will give me 10. So now I have my solution point, which would be 5 and 10. And look at that. From the origin to my interval, which is given as 5, let's add the word interval. We have a distance of 5 units. What about from my x-axis to my solution point? Well, now I have a distance of 10 units. So what can I do now? Well, do you see what shape is given to us? All of a sudden, we have to find the area of a triangle. It's correct. Very good. So the half of the base, which is 5, times the height, which is 10, that gives me 25 units squared. So let's make it a little bit more complicated. Well, what if they ask you to find the area of a semicircle? These are all concepts you'll be introduced to in your introductory period during integration. The area of a semicircle. So how can we find that? Well, before we can find the area of a semicircle, we need to know the following two formulas. The first formula would be the area, or the formula for a circle, which is x squared plus y squared is equal to r squared. R being my radius squared. So to find my radius, all I do is I square root the value that's given as r. That's it. Very simple. So for a semicircle, we have y is equal to the square root of r squared minus x squared. Just a little bit of shifting around, right? Algebraic manipulation. So this would be a semicircle. Now what if they ask you to find the area of a semicircle? And they give you the formula, well, x squared plus y squared is equal to 4. What do we do now? Well, first, we need to know how to graph a circle. So I'm going to graph a circle and I will indicate the area I found by a shaded region. But it's important that we can graph a circle as well when we get into integration. Ellipses, circles, hyperbolas, all of those are very important, and I will cover all of them. But now it's just an introductory lesson to integration, right? So first things first, I said r squared is equal to 4. So let's calculate the radius of my circle. So it would then be plus minus 2. The reason we can use both plus and minus is because my x-axis in quadrant 1, 2, 3, 4 have both positive and negative symbols. So we're going to go find 1, 2. So I will go 2 up, 2 down, 2 left, 2 right. Okay. And I can draw a circle. Now we know we're working with a semicircle. So what does semicircle mean? Well, a semicircle, if I look at my formula, it's going to be the square root of my x values and my r value. So then above my x-axis, because I cannot have a negative square root, if I have a negative square root, what does that tell me? Well, that tells me I'm dealing with complex numbers. right? So I'm going to avoid the negative values. So this would be the area of my semicircle. Now, how do we find this? Well, we know the area, or maybe we don't know, but I'll tell you, the area of a circle is pi radius square. Now, to find a semicircle would be the half of a circle. So what can I do? Well, to find a semicircle is going to be pi radius squared divided by 2, right? Why divided by 2? Because if we look at my function, or not a function, it's not a function. Why is it not a function? Because we can do something that's known as the vertical line test, which means if I draw a vertical line and my line crosses at 2 points, it's not a function. Okay? So let's talk about a shape. My apologies. Not a function. Let's talk about the shapes. So in this case, I have a semicircle. So I know it's going to be divided by 2. So let's input the values we have. Well, we calculated our radius. Our radius was 2. 2 squared is 4, divided by 2. So therefore, I can say, well, the area of my semicircle is equal to 2 pi units squared. And this will be my final answer, 2 pi units squared. Now you can go type this in on a calculator if you really want to. You'll find some insanely long decimal, infinite amount actually. But this would be the introduction to integration. Now, don't be fooled. It starts off very simple. I know, I made it seem very simple. But if you keep a level head and you understand these basic principles of what we're trying to actually achieve by integration. This is a high school level now, by the way. I'm speaking strictly of a high school level. I mean, some universities introduce integration like this too, but that's okay. But let's say we're given this shape. Say we're given this shape. And all of a sudden they give us an interval where they say, well, the interval is between 0 and 4. But let's say we have 1, 2, 3, 4, 5. We have 5 units. Okay. Now they ask us to find the area where the interval is bounded to the region 0 to 4. That means that if I draw a line here, this is the only area I'm going to calculate. I ignore the right part. Between 4 and 5, the units 4 and 5, I ignore this. Now, a problem a lot of high school students tend to make is they tend to calculate this into their final answer. So make sure you look at the interval. Very important. So how can we do this? Well, we can create a triangle, we can create a rectangle, and we have another rectangle. So we have region 3, region 2, and region 1. And then simply calculate the area of this, calculate the area of that, calculate the area of this. So let's go over all the formulas you need to know. Quick. So we have a square. The area of a square is side squared. The area of a rectangle is length times width. The area of a triangle is equal to the half of the base times the height. The area of a circle is equal to pi r squared. These are areas, by the way, not volume, areas. And then we have a semicircle would be pi radius squared divided by 2. And then we have, what else? What else is missing? Oh, trapezoid, of course, where we have the half of the base, half of the height, excuse me, multiply the sum of the two parallel bases. Okay, well done. You've started integration. So in the next video, I'll move over to some more complicated topics. And then later we'll get into some theorems.